Hello and welcome back. It is Thursday, December 10th, and we're talking about this week's space and astronomy news. So the amazing Japanese mission Hayabusa 2 just landed on Saturday. So the Hayabusa 2 mission was a sample return mission that went to the asteroid Ryugu. This mission was launched back in 2014, and the sample was actually collected in 2019, and now the sample is back. It landed Saturday in Australia and has been successfully returned to Japan. And this is a really fun fact, I thought. The Japanese astronaut Soichi Noguchi, who is currently on board the International Space Station, actually saw Hayabusa 2 as on its way back down to Earth. So cool. This is a really exciting mission, and I can't wait to see what scientists discover from this asteroid sample. Y'all, did you see the SN8 Starship test flight footage from yesterday? Okay, if you haven't, go watch it. But here are some highlights. So this was a test flight mission, right? And this is the one that Elon Musk, we talked about it last week, had given a 1 out of 3 chance of success. The original goal was to go to 15 kilometers, but they actually changed that to 12.5 kilometers. This was planned to happen sometime last week, and then it never really materialized. And then this week on Tuesday, everything was looking like it was going to go ahead, and there was actually an abort at T-minus 1 second. I was watching live, and the abort was so last minute that I thought that it was actually just a failure of the engines, but it wasn't. It was an abort. So they tried again yesterday, and this time the launch went ahead, and it was amazing. So the basic plan for this flight was to launch the rocket, have it go up to 12.5 kilometers, and then do the belly flop maneuver. So basically, the rocket goes up vertically, flops onto its stomach, descends horizontally, and then at the last minute before it lands, it goes back to vertical and uses the boosters to land. So this actually went off beautifully, but unfortunately, it had a little bit too much speed coming into the landing pad, and so the landing was a little harder than anticipated. But it was really kind of fun to watch. This is real. This is not like a movie set explosion. This was an actual rocket that crash landed during its test. But they still got a lot of great data that they needed from this test. It was basically a complete success. And so this is really exciting, and I can't wait to see what SN9 is going to do. Congrats to SpaceX. This is a really cool mission. Speaking of SpaceX, they also launched their new upgraded Cargo Dragon capsule for the first time this weekend. The launch was planned for Saturday, but it was delayed due to weather, and it went off successfully on Sunday. The capsule docked with the International Space Station on Monday, and it was a really great flight, so congrats. So NASA selected the first astronauts to be part of the Artemis team. So astronauts that make up the Artemis team will be chosen for Artemis missions, which means of these 18 astronauts, 9 men and 9 women, are going to be the first woman ever on the moon, and the first man on the moon since 1972, and I think the 13th man on the moon ever. So this is really exciting for these astronauts, I'm sure. All of their names are here. This was announced by Vice President Pence yesterday. So congrats to all these astronauts for being selected to the Artemis team. In fact, one of these in particular, I thought was really exciting. Kayla Barron, I don't know her personally, but she is a fellow alumna of the US Naval Academy, and she was only a year behind me, so I think that's pretty cool. And lastly, China put some really cool satellites into space today. So this is called the Gravitational Wave High Energy Electromagnetic Counterpart All-Sky Monitor, or GECAM. And basically these are 2 small satellites that orbit on opposite sides of the Earth, and together they can monitor the entire sky for the gamma ray bursts that are associated with the merger of compact objects that also emit gravitational waves. So gravitational waves from these mergers were first detected by the US in 2016, and very quickly after, China proposed this mission so that they can identify these electromagnetic counterparts, which is a really important component of doing what we call multi-messenger astronomy, where we can see things in both electromagnetic radiation and gravitational waves, which is really exciting because literally until 2016, we had never seen anything except in electromagnetic radiation. If these satellites detect one of these GRB events, then they can notify other observatories for more in-depth follow-up. So that's it for this week. Thanks for tuning in, and I'll see you again next week. Bye.